Hello and welcome to MariaDB OpenWorks 2023. My name is Edward Stover. I'm a Senior Support Technician for MariaDB. I am pleased to be presenting everything you ever wanted to know about replication but were afraid to ask. What is replication? Database replication is the frequent copying of transactions from a primary database on one server to a replica database on another server. The objective of replication is that both the primary and replica share the same data. The words primary and replica are synonymous with the older terms master and slave. To achieve replication, a connection is established from the replica to the primary. Replication can be used to achieve the following. Divide the work among multiple servers. You can use a replica to work independently without adversely affecting the primary. You can use a replica as a backup server, ready at all times for high availability. Replication can be maintained across geographic regions. You can replicate certain tables, certain schemas, or everything. Replication offers a variety of possible topologies. Host machines do not have to be similar. A replica can have different CPU power or RAM from the primary. Replication can be configured with an intentional delay, a method for reviewing the primary as it was in the past. There are three types of replication: asynchronous, semi-synchronous, and fully synchronous. Asynchronous replication is driven by the replica, which is tasked with requesting changes from the primary. Semi-synchronous replication is driven by the primary, which must wait to receive acknowledgement from one replica before a transaction is considered completed. Fully synchronous replication ensures that all nodes are equal before a transaction is completed. Galera cluster is an example of this. Keep in mind that Galera is a separate and different technology from replication. The MariaDB process has a number of threads that are used to manage replication. On the primary, you will find two threads: binary log dump thread and the ACK receiver thread, used when semi-synchronous replication is configured. The ACK thread receives acknowledgement that a transaction has completed on a replica. On the replica, there are slave IO thread. This thread pulls the binary log events from the primary and writes them to the relay log. And slave SQL thread, which reads events from the relay log and applies the events to the local database. If multi-threaded is configured, this thread will initiate worker threads that can write SQL events in parallel. Modern replication depends on Global Transaction ID or GTID. The GTID is made up of three parts: GTID domain ID, server ID, and GTID sec_no. The GTID domain ID is used to differentiate streams of transactions. Each server in a domain must have a unique server ID. The GTID sec_no is an increasing sequence which can identify single transactions. Use GTID domain ID to avoid conflicts. Here we see separate primary servers presenting GTID sec_no 100, which is a conflict. This is an example of where the primaries should have different GTID domain IDs. Binary logs and relay logs. A binary log contains a record of all changes to the database, such as create, alter, insert, update, and delete. If a change is logged in the binary logs of a primary, it will be applied to the replica. A relay log is a log with the same structure as a binary log. However, its contents are applied to the replica only. Old relay logs are automatically removed once all events have been implemented on the replica. If a replica is configured with log slave updates equals 1, then all changes applied via relay logs are also logged to the replica's binary logs. This is required when a replica is also a master in a replication chain. Understanding GTID global variables. The GTID binlog pause is the last event written to the binary log. The GTID binlog state is the last sequence for every combination of domain ID and server ID in history. The GTID current pause is the last transaction applied to the database. The GTID slave pause is the last transaction applied to the database by the server's replica threads. When GTID binlog pause and GTID slave pause are equal, it means that log slave updates equals 1. Binary log format. There are two binary log formats, statement and row. Statement binary logging simply copies the SQL statement into the binary log. It will be run as a statement on the replica. Row binary logging copies the contents of each row affected by a SQL statement into the binary log. The new row will be applied as contents of a row to the replica. Row format replication is more precise than statement. There are some downsides to row binary logging. It requires more work to be completed by the primary. It requires a lot more disk space. It will fail on the replica if changed rows do not exist on the replica. MariaDB offers a third configuration called mixed, which will switch between log formats depending on whether a given transaction is deterministic. Deterministic means that the value produced is always the same. If a statement is not deterministic, mixed will save a transaction in row format. If a statement is deterministic, it will save a transaction in statement format. This produces less work for the primary server and saves disk space. You can switch between statement and row formats at any time globally or within a given session. The logging process can save one transaction as row and the next as statement, and the next as row. The replica does not care how a transaction is presented, row or statement. It will simply apply it. Let's take a look at an example of how statement and row formats differ on a replica when a row that is updated is missing. On the top we have the primary, and on the bottom we have the replica. One row on the replica is missing. All commands are done on the primary. I set session binlog format equals statement, and I update the row that is missing on the replica. This is not a problem for the replica because it just runs the statement and finds nothing to change. Next, I set session binlog format equals row and update the row again. The replica cannot find the row and cannot apply the change. This breaks replication, and unless configured to ignore this error, replication stops. Replication can create some interesting topologies. Most people create topologies that are linear in nature. Although you can create a circular topology with replication, it is easier to manage a circular topology with Galera cluster. You can have multiple masters replicating to one slave. You can have MaxScale work as a binlog router to support many replicas. This relieves the primary from serving many replication tasks. One of the topologies that many of our customers create is the read-write split topology. The idea is that writes are sent to the primary and reads are sent to the replicas. If the primary dies, MaxScale can immediately reconfigure so that one of the replicas is promoted to primary and replication continues to the other surviving nodes. Unsupported topologies. Avoid replicating from a new release to an old release. The older version of software will not have all of the features that the new release has, and replication may not work properly. When it is time to update software, update the replicas before the primary. In some limited cases, you can replicate from MySQL to MariaDB. Consult the knowledge base for more details. Commands to manage replication. Use the stop slave command to stop the slave process. Start slave will start the slave process. Reset slave will erase the files master.info and relaylog.info, making the replica forget how to replicate. Reset master will remove all binary logs and reset all GTID related variables. Be very careful with this command as it will break replication. Set global GTID slave pause equals a GTID. This command can be run when the slave process is stopped. Show binary logs. This is a way to look at the number and size of binary logs. Show slave hosts. Run on master shows how many slaves are connected and from what machines. Show slave status. Run on slave to review current slave condition. Show global variables like GTID. View current GTID variable values. Use the MariaDB binlog program to convert binary logs to readable text. This can be piped into grep to search for certain events. The change master statement sets the options that a replica uses to connect to and replicate from a primary. In the demonstration, we will see how this command is used. There are three syntaxes for the changemaster2 statement that configure the method of replication that will be used. Master use GTID equals no, master use GTID equals current pause, master use GTID equals slave pause. Any of these three syntaxes can be used, but the only one recommended is slave pause or slave position. There are 90 system variables related to replication. On the screen, you see a handful of them that I think are important. Please take the time to review all of them by visiting the web page listed. Reviewing the globals will make clear all of the things that replication can do. There are 40 status variables for replication. Using GTID replication eliminates the need for most of them. Slaves connected and slave running will indicate if the replica is working. Let's briefly touch on the difference between physical and logical copies of data, which we will see in action in the demonstration. If you copy a file on disk to another file on disk, you have a physical copy. Maria Backup is a method of taking a physical copy of a MariaDB instance. If you extract the data from a database table and store it in a new format, such as a create table statement and insert statements, then you have a logical backup. MariaDB dump is a method of taking a logical backup. Scenarios for starting replication. I'm going to demonstrate building the topology that you see here. There are 4 steps. 1. Replicate the DRANAP database using a logical copy of data. 2. Replicate the Pandrea database using a physical copy of data. 3. Replicate the Pandrea database to Combi using a physical copy of data. And 4. Replicate the DRANAP database to Combi by applying the binary logs. Now we are going to look at setting up replication. We have 2 primary databases. The first is called DRANAP, which represents the activity of a company promoting and selling smartphone applications. The database is recording sales at about 1 per second. For this database, we are going to take a logical dump of the data and transfer that dump to another instance, import it, and start replication. The catcnf command is an alias to show the global options file for this machine. This machine has a GTID domain ID of 1 and a server ID of 10. By reviewing the GTID positions multiple times, we can see this database is processing transactions. The next step is to take a logical backup of the schema DRANAP. I know this schema includes functions, so I include them with the routines flag. I use the master data equals 2 flag to include replication setup commands, which will be commented out. The GTID flag will ensure GTID replication syntax. Next, we are going to create the user account for replication and another user account for querying. Now I copy the SQL dump file to the replica instance and SSH to that instance. I check that the dump file has been copied to this machine. Looking at the globals for this machine, we see it has the same GTID domain ID, but the server ID is 20. This machine also has log slave updates equals 1, which will allow this machine to be both a slave and a master to the next machine in the line. I want to be certain that the database instance has no previous use. To do that, I review and run a script that shuts down the running database, deletes all the data files, and creates a new empty instance. Now we simply import the dump file. Using grep, I obtain the GTID that is required to start the slave at the same point that the logical dump was taken on the master. I paste that GTID into this start slave script, then start the slave. I have a script that queries the number of rows on the DD downloads table on the master and on the slave. I see that the slave has the same number of rows as the master, and they are both growing. Our second primary database is called Pandrea. This machine represents the activity of a company selling tickets to events such as concerts and shows. Looking at the globals for this machine, we see that the GTID domain ID is 2 and the server ID is 15. By reviewing globals for GTID, we see that this database is actively processing transactions. I have a brief script that will take a physical backup of this database using MariaDB. I run this script, which saves a copy of the data files to a subdirectory of temp. Now I create the users for replication and queries. I SSH to the replica server. Reviewing its globals, it has a GTID domain of 2 and a server ID of 25. It has log slave updates equals 1. I have a brief script that will take the following steps. Destroy the current database, SCP the data files from the master to a similar directory on the slave, prepare the backup, copy the data files into the data dir, ensure proper ownership of the files, start the database, report the GTID from the moment in which the backup was taken. After running this script, we copy the reported GTID into the SQL script that starts the slave. I run the script to start the slave. Now when I check the TT sold tickets table, I can see that the primary and replica have the same number of rows and each is growing. Before we start working on the Combi instance, let's ensure that our instances on Dranap and Pandrea have the user accounts for Combi to connect to. Combi will have two slave processes, one connecting to Dranap and another connecting to Pandrea. Let's review its globals. It has a GTID domain ID of 3 and a server ID of 300. To begin, we're going to take a physical copy of pan 2 in the same way we did on pan 1. The restore on combi is the same script that we saw previously on pan 2. After running the script, we copy the GTID from pan 2 into the start script. We are going to start 2 slaves, so before we run this start slave script, we need to get the correct GTID from dran2. On dran2, we know that all of the changes that took place from the moment of the import of the dranapp schema to now are on the server in the binary logs. All we have to do is identify the GTID of the first command that was run, which we know was a create database command. Let's use the find command to get a list of all the binary logs. The log bin variable identifies where the logs will be stored and how they will be named. I use the find command to find files in that directory with the anticipated name. There are 2 files. I expand that find command to execute the MariaDB binlog command on each log. I pipe that output into grep, case insensitive, displaying 5 lines before create database. Searching through the output, I see create database dranapp, and a few lines before I see the GTID for that command. It is 1-20-61. In order to tell the slave to begin at 1-20-61, I need its slave position sequence number to be 1 less because the slave has not completed this transaction. So, we add the GTID of 1-20-60 to GTID slave position separated by a comma. A review of the script shows that we set the default master connection to a different name for each change master command. Naming each connection is required when replicating from multiple sources. After the editing is completed, I run the start slave script. Here I use another verify script that will select count on each server so we can see that they are all at the same place and growing. Changes on a replica that will not break replication. When possible, treat a replica server as a read-only server. Avoid performing DML on objects you are replicating from. Perform DDL or DML on a schema that does not exist on the primary. All of the ways for breaking replication from the primary involve turning off binary logging so that changes do not get saved and the replica never completes the same steps. The most common way to break replication from the replica is to insert, update, or delete rows that are later inserted, updated, or deleted on the primary. This is especially true when using row binlog format. Fixing broken replication. Replication has broken between our 2 Pandrea servers. Let's fix it and see what happens with the replication going to combi. You don't always find out why replication breaks. You just have to fix it. Someone informs us that one of the instances is not up to date. I start by verifying rows on combi. The rows on pan 1 are growing, but on pan 2 and combi they are not. This means that replication is broken. Let's go to the Pandrea machines. I SSH to Pan2. Here I have a very short script that shows the slave status. When I run it, I see the error could not execute update rows on table Pandrea TT sold tickets. What that means is that an update on the master cannot find the same rows on the slave. How could this happen? Well, I can think of two possibilities. Either one or more inserts on the master were not logged into the binary logs, or one or more rows were deleted on the slave. To fix the slave, let's log into the database and get an idea of what we are facing. The table has over 129,000 rows, which is too many to review one by one. The table has 8 columns, which makes doing this one by one even worse. Let's select this table into a text file that we can compare with a similar text file on the master. Select into out file is the command to do this. Now I copy the file to the master's temp directory. I return to the master, log into the database, and run the same command to select the table into a text file. I use the host name and the file name to keep the files separate. Now, using diff, I review the difference between the text files. The end of this output is not helpful. That is because the end of the output is showing all of the inserts that have taken place since replication broke. If we can fix this problem, these rows will get inserted. Piping the diff command into more, I see the problem immediately. The tables are different, starting at 138013 and ending at 138036. The rows 138071 exist on both servers, but they are different. This will get fixed when the update that broke replication completes. What I need is these rows starting at 138013 as insert commands. I'm going to use MariaDB dump to dump just these rows. I use the noCreateInfo flag to just dump inserts. Extended insert equals false outputs one command per row. And then I include the where clause because I only want rows between 138013 and 138036. Very nice. This is so neat. I'm going to save time and simply copy this output. I SSH to Pan2, log into the database, and paste those inserts. Now I start the slave. I run the slave status script. Looks good. I run it again to see that the GTID sequence is increasing. Let's take a look at this from Combi. Is everything in order? I run the verify script and I can see that all instances have the same number of rows and all instances are growing. Replication is fixed. Here is a brief review of some of the key points of this presentation. Thank you for your participation. I hope you've enjoyed MariaDB OpenWorks 2023.